So we're going to establish whether this series is convergent or not. And since we see an exponential and a factorial, let's just jump ahead and do the ratio test. So this is my term an, and the ratio test requires me to compute the limit of an plus 1 over an. So let's see what these are. An plus 1, I need to substitute everything where I see n with an n plus 1. So here n is in the exponent. Then I have n cubed, so this is going to become the quantity n plus 1 cubed, not n cubed plus 1. And that's going to be n plus 1 factorial, and then I just divide by the an, so like this. And now again I have a fraction of fractions, so I can just change that into a product. Let's do it here. So this times the reciprocal of this. Okay, and now we're just going to simplify what we can. So 3 to the n and 3 to the n, I'm just left with a 3. Now this cubed and this cubed cannot be simplified, but we can put them together. And these two can be simplified if you remember that n plus 1 factorial is the same as n plus 1 times n factorial. And this is simply because this is the product of all the first n plus 1 terms. So that's the same as the product of the first n terms, and then times n plus 1. So here, I'm going to group together these two. And I can bring them inside the same power. Then I have a 3. And then I use that formula, and that allows me to simplify the n factorial. So now, this limit is clearly going to be 0 because this quantity approaches 1 cubed, and then I have 3 divided by n plus 1. So let's factor out an n. So here we can divide by n. I get 1 plus 1 over n cubed times 3 over n plus 1. So this term approaches 1, while this term approaches 0. So this limit is 1 times 0, which is 0. And now remember, we're using the ratio test, so we're interested to see if this is less than or greater than 1, and clearly it's less than 1. So by the ratio test, the series is convergent.